So we're going to use those properties. We're going to use those properties that we talked about yesterday. Okay, so if you want to get that property packet out, you can. That way you can look through it as we go through each of these so you know why I'm using the reason that I choose. But when you're going through proofs or two-column proofs, you always want to make sure you're referring back to the picture that they give you. Okay? For geometric proofs, you want to make sure you're referring back to that picture and labeling it accordingly. So we're just going to jump right in. So we want to complete each proof. So this first one, I'm given O, so point O is the midpoint of segment MQ. So if I look at segment MQ, O is the midpoint. What does that mean about those two other segments there? Yes, they are congruent. So I'm going to label that on my picture. Okay, so since O is that midpoint of that entire segment, those two smaller ones are congruent. My second part that I was given is O is the midpoint of NP. Okay, so O is that midpoint between N and P. That means NO is equal or congruent to OP. So I can label that on my picture. Okay, so you want to label your picture with what you're given. So now I'm going to start going through my proof and telling the reasons for each step. So my first statement here says O is the midpoint of segment MQ. Well, that was what it told me in the beginning. Okay, so whenever you start, pay attention please. Whenever you start a two-column proof, you always start with what you were given. Okay, so your first reason is going to be your given. Okay, that was given to you. The second one, if I look at what I came to next here, I have segment MO is congruent to segment QO. I'm going to look at the picture. Okay, MO is congruent to QO. Well, I labeled that. Why did I label that? Because they are congruent. But why did I label that from what I was given? Because I was given a midpoint, right? So I can come to this conclusion because of the midpoint theorem. Okay, so I can say those two segments are congruent because I had a midpoint, and because of the midpoint theorem, they're congruent. Now if I move to statement 3, I have O is the midpoint of NP. Again, that was part of my given. Okay, that was part of my given. So I'm going to write given, because it was given to me. Yeah. So this one was given to me. This one was given to me. I have two of those statements here. Now, you can write them both at once, but sometimes it's easier if you write it partway through, because now in statement 3, I just stated O was the midpoint of NP. And now for statement 4, it's going to say NO is congruent to PO because of the midpoint theorem. Okay. All right. Next step, I have this angle. Okay, angle MON. So it's talking about this angle right here. Is congruent to angle QOP, this angle right here. So it's saying that those two angles are congruent. Why? Because they're vertical angles. Okay? That would be by the vertical angle theorem. Okay, so that's one of your freebies in your picture. That's why you always refer back to that picture. Okay, so if you see those, you have two intersecting lines. That means those angles across from each other are congruent because they are vertical angles. And I could say they're congruent because of the vertical angle theorem. My last part. I'm proving that these two triangles are congruent to each other. Okay, so triangle MON and triangle QOP. Okay, do you remember a couple days ago, last week, Friday, maybe? We talked about side, 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 angle, side, angle, 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 side. Those are your reasons to prove a triangle congruent. So now if I look at my picture, I have these two triangles I'm proving congruent by side, angle, side. So I can write side, angle, side. Decent? Okay, any questions about the reasons that I got for each of those statements?
Is there more?
Yeah.
Thank God.
All right, so
Oh, never mind.
next one, it gets a little bit more challenging.
Yeah, I looked at it now.
Number 2. Quiet. Number 2, we're given segment LA is parallel. Okay, that symbol means parallel to segment SN. Okay, so here, this segment LA is parallel, so I'm going to add in these arrows to show that it's parallel. Okay, so those arrows mean those segments or lines are parallel to each other. Now, also in my given, I have segment LR is congruent to segment NR. Okay, I can label that in my picture then. Okay, so labeling those two segments congruent. And we want to prove that triangle LAR, so this triangle here, is congruent to triangle NSR, so this triangle here. Okay? So starting with my first statement, I have segment LA parallel to segment SN. Well, that was one of the things I was given. All right, in my next statement, I have angle L, this one right here, congruent to angle N, this one right here. Okay, so it's telling me these two are congruent. Now I have to figure out why those two are congruent. Okay, well, I had this segment and this segment parallel. Now if I make LN a transversal through those parallel lines, okay, these two angles would be considered what? Alternate interior angles. Okay, so my reason behind this would be if lines are parallel, so if parallel, then my alternate interior angles are congruent. Okay, that was one of the last ones we did in that property packet, okay, from yesterday. So since I was given parallel lines, okay, I can find those two angles are congruent because they're alternate interior angles.
Given.
That is given.
Given.
Okay, so segment LR congruent to segment NR. That was part of our given statement up here. Okay, next I have angle LRA, so this one here, congruent to angle NRS. Okay, so these two angles here. What type of angles are those? They are vertical angles. Okay, so I can say they are congruent by the vertical angle theorem. Okay, so now I have enough to prove that those two triangles are congruent. So if I look back at my picture, I go from an angle to a side to an angle to a side to an angle. Okay, so those two triangles are congruent by angle, side, angle. Okay, any questions on my reasons here? All right, number 3. You want to do it on your own?
No.
Okay, number 3. We're given O is the midpoint. Okay, O is your midpoint of M to Q. That means those two segments would be congruent, right? So I can label that. I also have O as the midpoint of N to P. So again, we can label. Now we want to prove that triangle MON is congruent to triangle QOP. So we're looking at this triangle and this triangle. Okay? So make sure you're looking to see which triangles you're trying to prove are congruent, because there's 4, well, technically there's a lot more than 4, but there's 4 smaller triangles in here, so you want to look back to see which triangles you're proving congruent. So I shaded those 2 in. So now I can go over to my statements. That first one, O is the midpoint of segment MQ, was given to me. Next, I had segment MO congruent to segment OQ. Well, I labeled those two congruent because I had a midpoint of O. So by the midpoint theorem, I can say they're congruent. In number 3, I have O as the midpoint of NP. Okay, that was given to me. Next statement, I have NO congruent to OP. Well, I labeled that in my picture because of what I was given. I was given a midpoint. So again, by the midpoint theorem, they are congruent. Number 5, I have angle MON congruent to angle QOP. Okay, so it's telling me these two angles here are congruent because they are vertical angles. Okay, since they're vertical angles, we can use the vertical angle theorem. Okay, last, now I have enough information to say that those two triangles are congruent. So if I go in order, right, I go from a side to an angle to another side. So they are congruent by side, angle, side.
Guys, if you didn't realize
It's the exact same. That's why I asked if you wanted to do it by yourself.
I was over.
Any questions on those ones?
We have
0. You can
And if you don't like
abbreviate.
it, get out.
You can abbreviate midpoint like this if you want. I'll know what that means. Or you can abbreviate vertical angle with VA if you want.
Oh, VA.
But you still have to write theorem after it.
T.
To what?
T.
No. Sure.
Yes.
THD. The. Oh god. Oh god.
Relax. You'll be okay.
We should
I kind
do
of
this
started
one
this
around.
one and then I got confused, so I stopped.
All right. So, looking at number 4, we have segment WU right here, parallel to YV. I already labeled those with your arrows. Okay, so you know that those are parallel.
The WX.
Yeah, I know. I know. I'm also given that XU, where's XU? Right here, is parallel to ZV. Okay, again, those two are parallel. The last thing I was given is WX is congruent to YZ. So I'm going to label that on my picture right away. Okay? Now I can go over, actually, I'm trying to prove these two triangles are congruent to each other.
They are.
They will be,
Angle.
after we prove them.
Angle.
So here I have my two parallel statements. Those are both given to me, as well as my congruence statement. Okay, so all three of those I have in number 1 for our given. From there, we're going to look. Oh, angle 1 is supposed to be labeled.
See, that's why I got confused.
Yeah, I forgot to label angle 1. I'll get there. Okay, so angle W, angle 1 should be Y. Angle 2 should be X. So write that in. Alright, so in my statement, I have angle W congruent to angle 1. Okay, so angle W is here, angle 1 is here. Now I need to use what I was given to prove, find a statement that makes those congruent. So if I look at my parallel lines right here, right?
They're never ever going to cross.
They're never ever going to cross.
I know what you
Okay, and I look at Z to W as one straight line. I can make that look like a transversal, cutting through two parallel lines. When I do that, what types of angles are those two?
Parallel.
Not parallel.
Why it's not angles?
Not interior.
Exterior.
Not exterior.
I know what it is,
Corresponding
but-
angles.
They're corresponding angles.
There we go. I knew
Okay,
that.
those two are corresponding angles. Okay, so since those lines are parallel, we could say corresponding angles are congruent. So we'll say if parallel, then corresponding angles, so CA. And instead of writing congruent, I'm going to write my symbol.
So you're going to write it all out. I was like,
No.
I'm going to have to go down on the bottom of the page.
Okay, next one, we have angle Z and angle 2 congruent.
Oh, those ones correspond.
They are corresponding angles.
Told you.
Okay, except this time we're using the parallel lines XU and ZV with that same transversal there. Okay, so yes, these are corresponding angles. So we can say if those lines are parallel, then our corresponding angles are congruent to each other. Now I have enough information to prove those two triangles are congruent. Okay, so triangle WXU and triangle YZV. What would be my congruence for those two? Do you remember? If I go in order, what is it? Go in order. Angle, side angle. Okay, so if you go in order here, I go from an angle, I have an included side, and then I have another angle. So angle, side angle. Okay? Questions on this one? All right, next one, number 5. All right, again, we're going to start with our given and we're going to label our picture. It is labeled. So we have segment AB congruent to segment AD. That one's labeled right here. We have segment BC congruent to segment CD. That's labeled right here. And we want to prove triangle ABC is congruent to triangle ADC. So looking at our statements, my first one, I have my two congruencies. That was given to me. Now for the next one, I have side AC is congruent to itself. Okay? So I'm going to label that. Now if I have something equal to or congruent to itself, do you remember which property that is? It's in your packet somewhere. Something equal to itself. It is the reflexive property. Okay, so when you have something congruent to itself, it is the reflexive property. You do need to state that. Okay, so in your proof, we did need to say AC is congruent to AC because I have those two separate triangles and they have to have that congruent side. So now I have enough information to say that they are congruent and I have a side, and another side. Jack?
You're gross. Yellow's definitely worse.
All right, focus. All right, one more. I'm going to do one more. You'll have the last 3.
For homework?
Yeah.
Can you go back up? Ooh. Oh, thank God.
So, number 6, we're going to start by labeling our picture. Shh. Let's focus, please. We're going to start by labeling our picture. So we have MQ, this side right here, that entire side, congruent to side NP. Okay, so since it's a little bit hard to look at, we're talking about that whole side and this whole side. However, you need to label it so you know those two sides are congruent to each other. Okay? So this side and this side. Now we're also given MP is congruent to NQ. So I'm going to label that. Now we're trying to prove that triangle MPQ. So this triangle here is congruent to triangle NQP. So this triangle here. So those two triangles that we're looking at, those two triangles that we're looking at overlap each other. Okay? So they're overlapping. You see that? So looking at our statements, our first one was our two congruencies. That is your given. Next, we're saying side PQ is congruent to side PQ. So both of those triangles share that side since they overlap. Now if I have a side congruent to itself, again, that is the reflexive property. Okay, and I can label PQ congruent to itself. So now if I'm looking at my triangles, we have triangle MPQ. So we have a side, and this side. And then NQP, we have a side, and this side. So by side, I can say those triangles are congruent to each other. Okay, questions on those? All right, so, sorry, I can go back. So the last,